Step into a time machine, and let's rocket from the gritty construction sites of the early 1900s to today's high-tech marvels, where machines move mountains with a single command. The evolution of construction machines is a saga of human ingenuity, transforming backbreaking labor into feats of speed, power, and precision. From clunky, steam-powered rigs to AI-driven giants, these tools built the world we know, and they're not done yet. Today, we're exploring the evolution of construction machines, then versus now, comparing 10 types of machines from their early days to their futuristic forms. Get ready for a nostalgic yet forward-looking journey through engineering history. Welcome to Titan Machines TV, where we uncover the tech that shapes our world. We'll dive into 10 machine types, cranes, dozers, excavators, and more, comparing their early versions from the 1900s to the 1950s with today's high-tech models. We'll highlight improvements in speed, power, automation, and safety, spotlight industry milestones, and peek into future projections. With an educational vibe and a touch of nostalgia, this script will inspire awe for how far we've come and excitement for what's next. Let's roll back time and dig in. Number 1. Tower crane. In the 1920s, early tower cranes like the Wolf & Company models used hand-cranked winches and steel cables, lifting 5 tons at 2 meters per minute. Powered by steam or early diesel, 50 horsepower, they built skyscrapers like the Empire State Building in 1931, requiring 20 operators and risking frequent cable snaps. Today's Liebherr 1000 ECH cranes lift 50 tons at 10 meters per minute, powered by 500 horsepower electric motors. AI load sensors and automated balance systems ensure precision, cutting operator needs to 2 and reducing accidents by 70%. The 1947 invention of hydraulic jibs was a milestone, enabling taller lifts. By 2030, expect drones to assist cranes, boosting speed by 30% and building super talls in half the time. Number 2. Bulldozer. The 1920s. Holt manufacturing bulldozers with 60 horsepower gasoline engines pushed 10 cubic yards per hour, leveling land for highways like Route 66. Their manual controls and exposed cabs led to 100 fatalities annually by 1930. Modern Caterpillar D9 dozers with 450 horsepower move 50 cubic yards per hour. GPS-guided blades and vibration sensors automate grading, cutting labor by 60% and accidents by 50%. The 1950s introduction of hydraulic blades was a game-changer, tripling efficiency. Future dozers may use AI terrain mapping, projected for 2035, to double speed and eliminate operator risks in hazardous zones. Number 3. Hydraulic excavator. In the 1930s, Priestman excavators used steam-powered cables, digging 2 cubic yards per cycle at 100 cycles daily, aiding projects like the Hoover Dam. Their 80 horsepower engines and open cabs risked tip-overs, with 200 injuries yearly. Today's Hitachi EX 8000-7 excavators, with 3,800 horsepower, dig 40 cubic yards per cycle, moving 10,000 cubic meters daily. AI hydraulics and 360-degree cameras ensure precision, cutting labor by 70% and accidents by 80%. The 1960s hydraulic boom milestone boosted power tenfold. By 2040, autonomous excavators could triple output, reshaping urban foundations in days. Number 4. Concrete mixer. Early 1900s. Jaeger mixers, with 20 horsepower gas engines, mixed 1 cubic yard per hour, building early freeways like Germany's Autobahn in the 1930s. Manual loading caused 50 injuries yearly from spills. Modern Putzmeister M70 mixers, with 400 horsepower, blend 10 cubic yards per hour. Automated drum controls and sensor-monitored consistency cut labor by 65% and reduce waste by 40%. The 1920s invention of rotating drums was a milestone, enabling continuous mixing. By 2035, AI-driven mixers could optimize formulas in real time, slashing costs and speeding up mega projects like dams. Number 5. Piling rig. In the 1940s, Raymond pile drivers used diesel hammers, 100 horsepower, driving 5 piles daily for bridges like the Golden Gate. Unstable rigs caused 30 fatalities yearly. Today's Bauer BG50 rigs, with 600 horsepower, drive 20 piles daily. Laser-guided hammers and automated stabilizers ensure sub-centimeter accuracy, cutting labor by 75% and accidents by 60%. The 1950s hydraulic pile driver milestone doubled speed. By 2040, robotic rigs could use seismic AI to triple efficiency, building earthquake-proof foundations for skyscrapers in seismic zones. Number 6. Asphalt paver. The 1930s. Barber Green pavers with 50 horsepower engines laid 50 tons of asphalt daily for roads like the Pennsylvania Turnpike. Manual screeds led to uneven surfaces and 40 injuries yearly. Modern Vogel Super 2100-3. I-pavers, with 250 horsepower, lay 900 tons per hour. GPS screeds and thermal sensors ensure smooth roads, cutting labor by 70% and defects by 50%. The 1940s Tamper Bar milestone improved compaction. By 2035, autonomous pavers could double speed, using AI to pave climate-resilient highways in extreme weather. Number 7. Trenching machine. In the 1910s, Buckeye trenchers, with 30 horsepower steam engines, dug 100 meters daily for pipelines like the Los Angeles Aqueduct. Exposed chains caused 60 injuries yearly. Today's Vermeer T12553 trenchers, with 600 horsepower, cut 500 meters daily. Automated chain, tensioners, and radar-guided depth control reduce labor by 80% and accidents by 70%. The 1950s rotary wheel milestone tripled digging speed. By 2040, AI trenchers could use real-time soil analysis to quadruple efficiency, enabling rapid utility networks for smart cities. Number 8. Backhoe loader. The 1950s. JCB Mark I. Backhoes, with 40 horsepower diesel engines, dug 50 cubic meters daily for suburban developments. Unstable frames caused 80 tip-overs yearly. Modern JCB 5C ECO backhoes, with 120 horsepower, move 200 cubic meters daily. Telematics and automated stabilizers cut labor by 60% and accidents by 65%. The 1953 hydraulic backhoe arm milestone boosted versatility. By 2035, fully autonomous backhoes could use AI vision to triple speed, building infrastructure for urban sprawl in weeks. Number 9. Mobile screener. In the 1940s, PowerScreen Mark I screeners with 25 horsepower engines processed 20 tons of aggregate hourly for World War II airfields. Manual feeds led to 50 injuries yearly. Today's Terex Finlay 883 Plus screeners with 130 horsepower handle 600 tons per hour. Automated feed belts and vibration sensors cut labor by 70% and dust exposure by 60%. The 1950s vibrating screen milestone quadrupled output. By 2040, AI screeners could optimize sorting in real time, doubling efficiency for sustainable construction materials. Number 10. Road roller. The 1920s. Aveling and Porter rollers, with 30 horsepower steam engines, compacted 500 square meters daily for early motorways. Open cabs caused 40 heat-related injuries yearly. Modern Ham H25i rollers, with 200 horsepower, compact 2,000 square meters per hour. AI compaction meters and GPS navigation cut labor by 65% and ensure 95% uniformity, reducing accidents by 70%. The 1940s vibratory roller milestone tripled efficiency. By 2035, autonomous rollers could use thermal imaging to quadruple speed, building durable roads for autonomous vehicles. These 10 machines, from tower cranes to road rollers, have evolved from clunky, dangerous relics to high-tech titans, reshaping construction. Early models like the 1920s Wolf cranes or Holt dozers built icons like the Empire State Building but risked lives with manual controls. Today's Liebherr cranes and Caterpillar dozers, with AI, GPS, and automation, boost speed by up to 10 times, power by 20 times, and cut accidents by 70%. Milestones like hydraulic systems in the 1950s and GPS in the 1990s revolutionized efficiency. In 2023, global construction output hit $10 trillion, driven by these advances. By 2040, expect fully autonomous machines with AI vision, cutting build times by 50% and enabling carbon-neutral megaprojects. Visualize the 1930s. Workers toiling with steam cranes, dodging cable snaps. Now see today's sleek machines, guided by satellites, building cities in weeks. These evolutions didn't just speed up construction. They saved lives, reduced costs, and built a connected world. From Route 66 to smart cities, they've paved progress. The future promises machines that think, adapt, and build sustainably, creating skylines we can't yet imagine. Which machine's evolution stunned you most? Drop it in the comments, hit that like button, and subscribe to our channel for more journeys through tech history. Let's keep building the future together.